Matter is made up of invisible particles called atoms. Each atom has negatively charged electrons. They orbit around a nucleus which is made up of positively charged particles called protons and neutral particles called neutrons. The electroscope is made up of a brass cap, an insulator, an earth metal case with a glass window, a brass rod, a gold leaf, and a brass plate. The Van de Graaff generator is made up of a motor, 2 rollers, a belt, 2 brush assemblies, and an output terminal, which is usually a metal or aluminum sphere. When the generator is switched on, positive charges from the output terminal attract electrons from the earth through the water pipe. This flow of electrons causes the pointer on the galvanometer to move, indicating that electricity is present. Do you know what this is? It's a gigantic ammeter. This is called the voltmeter. Ooh, a comic book, my favorite. Ohm's law? Let's see. Current flowing through a circuit is dependent on the voltage and resistance throughout the circuit.
The law states that current which passes through a conductor is directly proportional to the potential difference across a conductor.
This is true, provided that the temperature and the other physical conditions remain constant.
I hereby find the defendant, Current, not guilty.
Yes, I'm free. Yay! Yahoo! What a weird comic book. Oh well, time to move on. Ooh, another hole. Hey, I'm back here again. Do you know what parallel and series circuits are? They are made up of batteries connecting wires and electrical components such as switches, ammeters, voltmeters, and bulbs. These common components are represented by electric symbols. Here, let me show you. Some of these components are the switch, cell, battery, and power supply, wires joined, wires crossed, lamp, fixed resistor, variable resistor, fuse, coils of wire, transformer, the galvanator, ammeter, voltmeter, two-way switch, earth connector, and the capacitor. Current will flow only through a complete circuit. A complete circuit is a circuit that hasn't any gaps. A gap occurs when a switch is open. This stops the current from flowing through the circuit. There are similarities and differences between a series circuit and a parallel circuit. A series circuit connects an electrical source with its components, one after another in a single loop. Current flowing through each component is the same throughout the circuit. The disadvantage of this circuit is that if there is a break in any part of the circuit, current flow throughout the whole circuit is cut off. In a parallel circuit, the current source is split into two or more branches. The amount of current flowing through each branch in the parallel circuit may be the same or different. However, it is certainly less than the current flowing out of the electrical source. The current entering any junction in the circuit is also equal to the current leaving that junction. So, that was the difference between the two circuits. But we haven't talked about the current, voltage, and resistance between the two circuits. Let's take a look at the series circuit first. The current at every point in a series circuit is the same. The sum of the potential difference in a series circuit is equal to the potential difference across the whole circuit. Each resistor will reduce the current flow, and its resistance adds to the total resistance of the entire circuit. As there are no wire junctions in the circuit, and all components are placed consecutively on the same path, current flow will decrease if more components are added. But adding more batteries to the circuit can create larger currents. But if a component in the circuit fails, then all the components in the circuit fail because the circuit has been broken. The current from the source is the sum of the currents in the separate branches. The potential difference across two or more components connected in parallel to each other is the same. As more resistors are added to the circuit, total resistance will decrease. Each resistor acts as an alternative path for current flow. If a component in the circuit fails, the others stay lit. This is because a parallel circuit consists of more than one branch, and it has to break down in more than one place before the other components fail. The power supplied to the circuit also lasts longer. The disadvantage is that batteries that are connected in parallel will produce the same amount of current as one battery. So what are the similarities and differences between series and parallel circuits in terms of current, voltage, and resistance? In a series circuit, currents at any point in the circuit is the same. However, current in parallel circuits is the sum of current in its individual branches. In a series circuit, voltage can be increased by adding more batteries to the circuit. However, adding more batteries to parallel circuits does not increase voltage through the circuit. In a series circuit, the total resistance in the circuit is the sum of all the individual resistances in the circuit. In a parallel circuit, it's the sum of the reciprocal of each resistance. Ooh, free energy. Ooh. A magnet. A magnet is an object that has the ability to attract magnetic materials such as iron, cobalt, nickel, and me. A bar magnet has two ends called magnetic poles. They are the north and south pole. When the magnet is hung freely from a thread, the north pole will always point to the north of the earth, while the south pole points to the south. This property of a bar magnet makes it suitable for use in a compass. A compass is used by ships at sea and airplanes in the sky. A magnetic field is the region around a magnet in which magnetic forces act. If the magnetic field is strong, the magnetic force is big. If the field is weak, the force is small. Magnetic field lines differ according to the arrangement of the bar magnets. If there are many field lines that are close together, this means that the field is strong. No two field lines can cross. Each has its own power. When unlike poles are near each other, the field lines attract. When like poles are near each other, the field lines repel. Where two fields cancel out, there are no field lines. This is called the neutral point. When field lines are spaced equally with all lines pointing to the same direction, it is called a uniform field. A little bit more. Ouch! Electromagnetism is the use of electricity to turn a piece of metal into a magnet. An electromagnet is a magnet produced by electromagnetism. It is made up of a piece of iron wound with a coil of wire. As current flows through the coil, the iron becomes a magnet. When the current stops flowing, the iron loses its magnetism. Electromagnets can be made stronger by increasing the amount of current flowing through the coil or increasing the number of coils. Okay, that's it. No more playing around. I'm leaving. Where's the exit? Let's look at what we have learned today. The current at every point in a series circuit is the same. The sum of the potential difference in a series circuit is equal to the potential difference across the whole circuit. Each resistor will reduce the current flow, and its resistance adds to the total resistance of the entire circuit. The current from the source is the sum of the currents in the separate branches. The potential difference across two or more components connected in parallel to each other is the same. As more resistors are added to the circuit, total resistance will decrease. Each resistor acts as an alternative path for current flow.
Hello? 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 Is there anybody here? Hello? Strange indeed. Can anybody hear me? Hello? Can anybody hear me? Ouch! Huh? Hello? Hey! Hey! Help! Help! Get me out of here! Can anybody hear me? Hello? Help!
Blah, blah, blah.